today, in terms of what we want to accomplish, the big things are the first assignment. We want to go and take a look at that and give you some guidance about that. I guess Raj has had you download the starting point file. We can talk about what's in there and how we're going to use it. And we're going to talk a lot more about just modeling of walls and doors and windows and the whole building envelope, really, as we start thinking about our building designs, thinking about that outer skin that separates us from the external environment and really how we model a lot of those features in a little more detail, looking at, kind of conventional doors and windows, but also starting to look at curtain walls and systems that are kind of groovy in terms of being able to kind of design things in the way we like to actually do them these days. But let me go ahead and start with the assignment, because I think that's something that a lot of you are probably thinking about. And to do that, we'll go over to coursework. Keep my section active? Sure. Actually, what I'm going to do is I'm going to open it up in Word, because it's a little bit easier to read in Word when I do it that way. So I'll open up the assignment over there, but this should be the same thing that you're actually looking at on coursework. And let's talk about what the assignment is. Okay. The idea is we want to go ahead and start creating a simple structure, and we're going to start with wood framing as a construction technique going. I like to start with wood. It's pretty simple to understand how it's built. A lot of you have had experience with that, especially if you're from the U.S. or an environment where they do a lot of wood frame construction. You've seen houses being built. You have some sort of sense of what it's like. As we go through the course, we'll try different technologies. We'll move into steel, we'll move into concrete frame construction, which may be more familiar from other parts of the world. Okay, but we'll start with wood just because it's kind of simple in the scheme of things. Okay, and we're going to go ahead and try to design a very simple structure, one that would be appropriate as for a field research station, something that could be located up at Jasper Ridge or somewhere on campus as a place for people who are working in the field to check in and kind of just work on sort of their field notes, maybe meet with some other students, pick up equipment, store equipment, kind of a relatively small little building that might be appropriate for some place like Jasper Ridge. Okay, in terms of what we're going to do, the assignment's going to be due next week at midnight, so go ahead and just kind of plot on that. And then I think that Raj has advertised a little about how the office hours are going to work this Thursday, and we have some set up next Monday during the day to kind of give you some help with that. So please go ahead and come on in with your questions so that we can kind of use the time wisely. What we'll do is basically when you come on in, just sign up on the board and just start knocking them down one at a time. It's like desk consults to help you get through some of the issues you may be having. Ultimately, we're going to create something called a DWX file, so a file that contains your 3D model as well as these sheet views, and put that up on the coursework website in your Dropbox. But we'll show you how to do that a little bit later today. Okay. In terms of the building we're going to create, you can use 2013 or 2014, and you're going to do this small research station. And what I actually like to do is just really kind of give you a program to work with and then let you exercise your own creativity and kind of thinking about what that building may look like. So here's what the program basically looks like. You're going to do this space for some student researchers. You want it to be a shining example of sustainable design, like we like things here at Stanford to be. So as we go through and do it, things like, well insulated, takes advantage of passive light and solar energy and wind, natural ventilation, things like that. Those are things you should sort of be thinking about as we start designing this. It's a pretty simple little structure, but hopefully we'll have some nice little features and kind of make it a nice citizen in a sustainable world. Its total size should be around 500 square feet. And that's actually not a very big space. Think about sort of 10 feet by 50 feet, 20 by 25. It's somewhere in there, so it's not all that much bigger than this room. It's bigger than this room, but not all that much. Maybe this room and the room next door. Okay, so don't be thinking in terms of it's not a 3-bedroom house out in the country. This is it's a small workstation. Okay. The space that we're going to have is going to have some space for the researchers to work, 3 or 4 desks. It'll each have about 40 to 50 square feet. So when I think about a desk, it's again, not kind of the executive desk with a credenza and the secretary positioned outside. It's nothing like that. It's more like kind of 5 by 8, maybe 5 by 10, kind of like a cubicle. Just some little space to work at, some sort of desk or a workstation, just a rolly chair, a place to put down your laptop computer, stuff like that. But you aren't living there. You're just kind of like camping out for a couple hours. It'll have some sort of long lab bench, about 8 feet long. That could have a sink, maybe some space to put your instruments, some lab storage space underneath the countertop, something like that. A little meeting area, and again, don't think conference room. Think about that corner of the room that has a table and a couple of chairs and a whiteboard on the wall. Just a little meeting space. Okay, not necessarily. So as you think about this, this room probably doesn't have, this building probably doesn't have a lot of hallways and corridors. It's a fairly open space that maybe, you know, just by the way the room, the walls are arranged or the furniture is arranged, you're sort of indicating spaces within it. Okay, but it doesn't have a lot of hard separation. Okay, a small storage room, maybe that'll be a separate room, like a big closet, kind of 8 by 10, someplace where you can stash things away and just have them away. That can have access from the inside. You might want to be able to have access from the outside. You know, just kind of whatever seems to make sense. A bathroom of some type, a single stall bathroom that'll have a toilet and a sink. And as we're starting this, it'd be great to think about what an ADA compliant bathroom looks like. So one that's actually designed for people with disabilities, okay, to allow equal access for everybody. And the basic configuration of an ADA compliant bathroom is bigger than you probably think it is. It needs to be about 5 feet by 8 feet. And the reason isn't, you know, the toilet doesn't take up so much space in the sink, but it's, you have to allow basically room for a 5-foot diameter circle that you can spin around in and have access to all the different fixtures. And if you're sort of wondering what one of these looks like, if you go over by Koopa, those single restrooms there, or even over in Long, most of the single restrooms on campus are ADA compliant. So just going to take it, look at how they're arranged. You have a wall-hung toilet, there's some room to kind of maneuver around. The sink will be like a wall-mounted sink. It won't have like a cabinet underneath it. But there's also a lot of good guidance on the web. So yeah, just allow enough room. Like that teeny tiny squishy bathroom probably won't be big enough to get a wheelchair in. Okay, so try to be sensitive to that. In terms of your sustainability features, think about how you're using the windows. You know, are there windows to the south that'll capture some nice heat during the day that maybe will radiate off the floor and kind of keep the place warm? We don't want to have any active heating or ventilating or air conditioning in this. It's pretty much just passive. So think about some nice south-facing windows, maybe some north-facing windows that'll get some nice daylight in throughout without ever getting direct sunlight. They're probably operable, so you can open them up on those hot summer days when it's going to get stifling in this place. You know, so you can have some nice cross breezes through the building. Also, you know, think about where we can actually mount some photovoltaic panels if we want to try and use some energy generation. You can think about where you might put a wind turbine, something like that. But just keep thinking about ahead how the people are ultimately going to use this and ultimately have a really kind of nice sustainable structure. In terms of the construction methods, if you've never really worked with wood frame construction, let me give you just sort of the briefest of primers in terms of how it typically goes. Like for a very small building like this, it's very common that we put things on a concrete slab of some type, as opposed to building them up. We could build it up on a foundation and have a crawl space. But for a simple building, we'll often put it on some sort of concrete slab. So we'll have some sort of earth, and on top of that, we'll place some sort of concrete slab. I'm going to draw this in section. So the slab might look something like this, and it's going to be about 6 inches thick. And if I really got precise about it, and we don't need to do it for this first model, but we're going to really ultimately start doing is really putting some detailing in the slab. So really the slab would probably have a little edge detail that looks like that, where we thicken up the edges under the places where the bearing walls will come down, just so that they don't crack right there. We want to have a little extra support. It's like a little footing built into it. Okay. On top of that, we're going to put some light frame wooden walls, and those are what we call stud walls. In terms of what's going on with those walls, we'll have layers to them. The middle structural layer will be the 2x4s or 2x6s. For this structure, I'd recommend 2x6 lumber, because that'll give us room to put R19 insulation. Really kind of insulate it very, very well. Now, just so you know, 2x6s really aren't 2x6, they're really 1.5 by 5.5. The 2x4s are really 1.5 by 3.5, more or less. So there's a nominal size as well as the actual size. Just watch out for that, because we're going to get you every once in a while in terms of thinking about the thicknesses. But we've set up some wall types in the starting point file, which Raj had you downloaded, that actually already set up to kind of include some of these layers. We'll take a look at that in a minute. Okay, so we're going to put some walls in here. And what we'll typically do with a structure like this is we'll actually place the walls so that the studs of the walls, those 2x4s or those 2x6s, actually come right so they're perfectly aligned to the edge of the concrete. Okay. In what we're going to talk about in building modeling technology, this will be the core of the wall, the structural core of the wall, and we're going to try and get it to align so the outside face of the core is aligned with the floor, basically. And in terms of drawing this detail, there's often a bottom plate and some top plates. We won't have to model those in too much detail. We're just going to model walls. But In addition to that core, that'll have some insulation inside of it. And again, we don't really model that. We just call it an insulated wall and give it some properties. So there's some insulation in there. Okay. There'll be sort of layers on the outside and layers on the inside. Okay. On the inside, often in structures like this, we'll have like gypsum wall boards. So this stuff. Okay. It could be lath and plaster, but it's typically now it could be wood. But gypsum wall boards are very cheap, inexpensive material. So there might be a ½ inch of gypsum wall board on the inside core, or on the inside of the core. Then on the outside of the core, there's going to be a couple layers. There's typically, for something like this, some sort of a plywood layer, a sheathing layer that provides some lateral resistance. So if there's an earthquake or just resistance to wind, it keeps it from, if I have a wall that looks like this, I'm going to look at an elevation view. It has the studs, it has all these vertical members. If I apply a lot of force here, what will happen is it'll wreck. It'll do that and kind of tip over. In fact, a lot of buildings fail in earthquakes in that way. So what we do is we put a layer of sheathing, some like plywood on the outside that'll keep it from doing that, keep it from wrapping. So in the section view, there'll be some sort of layer of plywood. There'll also be some layer of some outside material. And for the outside materials, okay, think about Stanford and some of the buildings you see around here. What sort of outside materials do you see on like the dorms, the frat houses? Like what sort of materials are you used to seeing on the little wood frame construction around here? What's the most common one you see? Siding. Siding is a very common one. A lot of the older houses have some sort of lap siding. Okay, so there's some layer out there that looks like that. Okay. That's just another layer. Okay. What are some of the other materials you see? Stone you actually see too. Often we'll do stone kind of at the lower part of the wall. So there might be some stone kind of layered on here, kind of stacked up. A very common material on campus, almost all the buildings, is stucco. Okay, stucco is really just cement plaster. We call it stucco when we put it on a wall. But it's be about 1 inch of cement that's kind of on the outside here. Very durable, well, relatively durable. It still cracks, but it's good for thermal things too. It sort of absorbs a lot of heat during the day, re-radiates it throughout the day, so it gives a little bit of thermal mass. Another material you might have here is like shingles. On some of the older houses, you have like cedar shingles that are painted or stained, something like that. But the cool thing is, like, there's 3 or 4 different wall types that are used here on campus, but the way we're going to model it is very similar. We're always going to keep that wood frame, the core, in line here. And we'll just sort of swap in and out different materials on the outside. And we'll do that by changing wall types. And I'll show you in the starting point, a lot of those wall types are already defined for you, and then we can start customizing it to create your own wall types. But that first template, part of what it has is the different wall types in it. Okay, so we'll have some walls. And there'll probably be a wall over here too. Then we have some sort of roof on the structure, and depending on how a roof works, we might have it singly sloped or doubly sloped. Just based on the sizes of this building, you know, if this distance across here is, let's say 16 feet or less, okay, you'll probably have a very simple sort of structural system where it'll just be these members that cut across that I'll call rafters, which are kind of like studs of walls, but they'll just kind of cut across like this. Okay, and these things, again, sort of spaced out about 16 inches, will be either 2x8s or 2x10s. When we indicate the spacing between them, we'll say, that'll be at 24 inches on center, and that just means that there's a series, every 24 inches is about one of them. But this is what I mean by this. It's probably going to be something like this. The good news is, you're not going to really have to worry about that structural part just yet. You're just going to put a roof that is assumed to have some structural members in there. Later we'll learn how to actually model all the structural members within there. But just sort of as you're thinking about the roof, it might be sort of a simple roof like this. If it's a bigger building, or if you want to get some clear story windows, you might have a structure that looks more like this. We'll put walls on both sides still. But maybe, we'll have a roof coming up from this angle in this direction. We'll have some other roof coming up, and we'll leave some sort of gap in there where we can put some windows, some clear story windows. And when we do something like that, no worries, we put like a beam in here, just kind of support it and hang everything off of it. But in terms of what I'm expecting on this one, if you want to go with a really simple roof system, super. If you want to go for something a little more elaborate, great, but realize you're sort of chewing off a little more modeling. Okay, and as you approach this whole building, definitely This building, this is not your magnum opus. This is the first of many buildings you're going to do. So go ahead and keep it simple and design, be creative, but don't overtax yourself. It doesn't have to be the world's best building. Some of you will have fantastic little buildings, and other ones will have kind of big garden sheds. And that's okay. Just the important thing is just that you're using the modeling tools, right? Okay. Last thing we need to worry about, just for ADA compliance, any doorway has to be at least 32 inches wide, so we can sort of wheel a chair through there. And if there's any hallways, there probably shouldn't be that many hallways, but anything that looks like a hallway should be at least 36 inches wide. There's plenty of room to kind of pass through. Okay, so that's kind of the general idea of the construction technique. In terms of getting started, again, there's that file that you've downloaded, hopefully. That'll get you started. It has a lot of these things built into it. And then here's what's expected and just how to think about the units. So we try to scale this in a way that sort of makes sense so people can take it at different levels and get into deeper levels with it. So if you're just really going for the basic class and want to do the minimum for 2 units, put the walls, the doors, and windows, just sort of make the box. Put a roof on it, and ultimately produce a floor plan and a roof plan for that. And we're going to show you how to do that stuff today. If you're going for 3 units and you're going a little bit deeper, great, we're going to go a little further. You're going to go ahead and add in the infill objects. So put some furniture in, put some plumbing fixtures, just go into the modeling in a little more detail because we're really filling it out. And then add a couple more views, some exterior elevations in the building sections. It's really not that much more work to do all this stuff. It's really just adding a little more detail and adding a few more views. But we'll get you a little further. If you're going whole hog, you're taking it for 4 units, you'll do those things. And also, we'll show you how to create a couple scheduled views that just pull that information out numerically as tables. And show you how to set up a formula in a table. So if we have windows, we can figure out which area the windows are. So that's kind of the idea. Just kind of scale up a little bit. Ultimately, you're going to go ahead and take this model as well as the sheets that you put together showing these views and plot them out as what we call a DWF file. That's just a 3D, it's a file format that we can share models with. It's kind of like PDF in that almost anyone can read it without a modeling application. But the cool thing is it's not just the lines to be printed, it actually contains all the model information. So if I want to quantify or interrogate or do something more active with it, I can use that DWF file. So it's just an interchange file for building models. And you're going to take all that stuff, put it together, and ultimately put it on the coursework drive by next Tuesday night. Does that sort of make sense? Any just general questions about the scope of all that? Or does it kind of make sense? This sort of notion of the construction technique sort of make sense? Okay, we'll go through and show you how you model to kind of get that. But that's, wood frame construction, not even 101. That's like 001 or 5, just the beginning of wood frame construction. And again, if this looks very foreign and alien, no worries, we're going to get to something that will look better to you, like a little bit later in terms of if you're from a part of the world that likes concrete or steel-based construction. Okay, then if that feels comfortable, let's kind of put that all aside, just dig into sort of doing something with the walls, and doors, and windows, and stuff like that. And along the way, we'll sort of show you specifically how we'll do the modeling for the assignment using that template, okay, as part of the examples. So to get us going, what I'm going to do is let me pull up some random slides. Well, not random slides. There's actually slides that are hopefully relevant to what we're doing today. I say weird things. Okay. And let's think about the building envelope. Building envelopes is really how a lot of people perceive the buildings, and there's essential elements that are really going to be considered as part of it. We think about just the whole exterior wall surface, and within walls, there's this whole notion of elements which are hosted by walls, windows, doors, openings we put in them. But in our hierarchy of thinking about things for building modeling, those things are considered to be part of the walls, the kids of the walls. Okay? We'll think about roofs and curtain walls and columns. Those are all part of it too. We'll get to roofs next time. Columns next time. But there's all these different elements that are ultimately part of the overall building envelope that we need to consider. And as we think about the building envelope, you got to realize you're designing it from all these different considerations. Designers often think about it aesthetically, so we're going to think about, oh, well, I want a solid surface, and I'm going to contrast that with a very skeletal, very visually connected surface. We can think about the materials and how sustainable those materials are to make sure we're actually doing good things on that front. Functionally, we're going to think about supporting the loads that are coming down from the roof, as well as just kind of separating the interior and the exterior for rain, for thermal protection, with all the things we do. Yeah, as we design the walls also, though, it's important to start thinking about ahead of the process of how we're going to construct it, so that we can actually, as we're modeling, think about what the construction technique is and make sure we're modeling things in a way that's going to support that. Okay, as we place walls, you're going to find there's two types of properties. In fact, for every object we place, every type of building element we place, there's two types of properties we're going to consider. There are things which are called instance properties, which are particular to one particular instance of that element. So as we go through and place walls, there are 4 walls in this room. And in a lot of ways, these 4 walls are very similar. I can say these are interior walls that are made of sheetrock. Those are a little bit different because they have this polycarbonate at the top, but there's 4 walls which are pretty much the same type. Okay, this is an instance, that is an instance. There's 4 different instances around here. So the notion of really what the height of the wall is, and also what's considered the location line, which we'll talk about in a second, that's considered an instance property. This one's height and that one's height could be separate from each other. Okay, and we set those independently. The issue of really how the wall is constructed is a type property. So if I'm going to put half-inch sheetrock on this wall, I may also want it on this one, that one. All the walls of the same type will share the same properties. If I decide to make that 3/4 inch or 1 inch, they would all inherit it because they're all of the same type. So get used to thinking about things in terms of instance versus type. Okay, that'll help you out. So in terms of instance properties, the big ones to get started with are the location line and the top constraints. And let's just sort of build something. It'll make more sense if we actually try to do that. Where I'll come on over into Revit. See if I can find Revit in there. There it is. I'm just going to open up, not the template, but you can work in the template model for the starting point if you want. I'm going to just work with a generic architectural template and get started there, because there's some more wall types in there. So I'm going to say let's create a new project, and I'll start with the architectural template. Now, again, the template contains families, wall types, roof types, floor types that have been predefined. The reason you can start with the starting point is that there's already some defined for you, which will be handy for the assignment. I'm starting just sort of with the default ones out of the box. We can change that around as necessary. Okay. Notice again, views on this side, properties palette on that side. So as we go through and we start our exercises creating some walls, let's go to the wall tool. Okay. I can choose my wall type over there, and I'm just going to leave it as a generic 8-inch wall for right now. You'll notice even before I place some walls, there are some options that are available. One is the height of the wall over here, then there's the location center line. That's going to affect the instances I place down. Okay. You can also sort of see those properties over here in the properties column. But let's start by just placing some walls. I will start with placing some walls. Oh, I'll just use the line drawing tool, and I do like to go to level 2 as opposed to unconnected. That just sort of makes me happier to have them constrained by that. I'm leaving it wall center line. Yes?
On my floor plans, I have first floor and roof plan. I don't have level 1.
Okay, you're starting with a starting point. That's okay. For yours, just go from level 1 to roof.
Okay.
Yeah, that's okay. It's because you're using the model starting point from the assignment. No worries. Just go from level 1 to roof. Okay. I'm going to draw some walls, just kind of stretch them out here. Notice they're set to wall center line, and let me even zoom in to kind of give you a highlight of what's going on. As I draw the wall, notice there's that little green dashed line, which is indicating where I'm actually drawing the line. You can see the wall's being centered on that. Okay, and that's kind of okay. For generic walls, it doesn't really matter a whole lot. You can leave them centered, and they sort of work out okay. Let me zoom back out again, Z-O to zoom out. I'll pop it back over here. I'll heal it back up, and I got some basic walls. Now, generic walls, the cool thing about them is there's only one material, and it's sort of even unadvertised what it is. So they're not too fussy about the notion of where your location line is. When we start getting walls that have a bigger thickness and have different layers, the inside and the outside layer, then it becomes more important to kind of think about where the location line is. And let me show you what that might look like. So I'm going to go back to wall again. Only instead of choosing generic, I'm going to choose one of the layered assemblies, and there's some up at the top. I'll choose one, brick on metal stud. You can sort of see it has a bunch of different layers in there. That's got some core layers, a sheathing layer, some air, and some brick. There's some different layers in there. And as I go drawing those, now this is going to get to be more critical about this notion of, am I centering it? Am I putting it on the inside or the outside face? And let me kind of show you what I mean. I'll start by placing the wall just on the wall center line. Yep, Raj, grab on in there. And when I place the wall on the wall center line, in a lot of ways this is going to look very similar. Okay. As I'm placing it, you might notice that I'm not really seeing all the layers of the wall. The reason I'm not seeing all the layers is currently this view is set to kind of a coarse level. It's not showing me all the detail. If I want to see all those layers as I place them, I'm just going to turn that up. So I'm going to just turn that view from coarse all the way up to fine, so I actually could see all those layers. And now when I go through place that wall, you'll see that it's still centerline based. Okay. We'll place that wall. Let me do this. I'm going to actually go through and draw something called a model line. A model line is kind of like a construction line. Just kind of draw it through there. So we just sort of have a little frame of reference for placing some more walls. And place some walls in a different way. Let me zoom on in even. I'm going to grab the little zoom tool. Come on in there. Okay, so I'm going to place another wall, but this time I'm going to change its wall. So as opposed the location line, so as opposed to wall center line, let me place it so that it's the finish face exterior. And if I go through and click right on the line and place it, notice that it's going to put all of the wall on the side of where I'm clicking right now. Okay, so it's putting the exterior face there. If I draw a third wall, and I change it so it's finish face interior, and draw that same place, it's going to put the interior surface there instead. Now, all this messing around with location lines, it kind of seems like a lot of detail at first, but it's kind of an important thing that happens relative to the location line. We can always fix this later. If you get the location line right, let me show you what it does have an impact on. Okay, the location line that a wall has is actually, it's considered the hard part of the geometry that's not going to move. So if I change to a different wall type that is a different thickness, wherever surface is on the location line will stay put, and everything else will move relative to it. Similarly, if I flip the wall, it'll stay put. So, here I am hanging around. I got that wall over here. The location line is right there where the green is right now. If I say flip that, by clicking the little flipper, notice the whole thing just rotates over to the other side of the location line. Similar thing with this one, if I flip it, it'll flip over to the other side of that. So it's important from the notion of flipping. It's also important, though, for the notion of really if you change the thickness of the wall. So these walls have been placed based on the exterior surface. Oh, I'm going to show you something else that's actually very useful for you when you're doing this. You might notice that these walls have this big fat line around the outside, so it's kind of hard to see precisely what's going on. By default, Revit shows kind of full thicknesses, just exactly how it's going to look when it plots. So you get these big fat lines. Sometimes you want to turn them off though, because you're sort of obscuring some of the detail that you want to see. So if you do want to turn that off, go to the View tab. And on the View tab, you can actually go through and just click, it's right over here. There's a thin line mode, fat line mode. So thin lines, we'll just thin them out. It just toggles between those two different modes. And I just like to do that sometimes because I can really see that the line surface, it really does match. Okay, so these walls, which are constructed on the outer edges, the kind of exterior face and the interior face, the finished face interior, okay, they're kind of hanging there, they're looking pretty good. If I choose that wall, I can sort of see, it's based on the properties palette, kind of what it is, the finished face exterior. If I change that wall to a different type, for example, I change that from brick on metal stud to brick, or how about CMU insulated, so some wall type with a different thickness. When I go through and change the wall type, notice the location line of that individual wall stays the same. So the wall grew to the inside. Similarly over here, if I change that one to some other type, oh, like exterior foam on metal studs, it'll change holding that line constant. So it does seem to be sort of a little bit important in terms of where the location line is located. Okay, but again, don't worry if you don't get it right the first time. We can always go back and fix it. Okay, let's try this. Okay, so this line, if I am betting, I'm betting this is the core of the wall. That's probably the finished face or the core face right there. On this one, this is the studs, that's the interior face. Maybe locate there. If you want to go through and change walls, but not have them move based on the finished face, but instead you'd like the studs to stay in place, okay, and then just have the finishes change, what you need to do sometimes is actually just change the location line of the wall before you change the wall type. So for example, right now this one, the location line is the finished face exterior. That has been fine so far, but if I want to go through and change this wall now, but have any change hold constant so that stud layer always stays in the same place. So it doesn't shift around relative to the foundation. Okay, what you can do is this. Choose that wall. One of its instance properties is whatever its core is, or whatever the location line is. You might want to change that. And I can say that, great, I want the core face exterior to be the location line. Okay. What I just did there was I said that, okay, I'm going to draw another line just to let you know where it is. I'm betting that it's right there. Okay, and we'll show you how to determine that in just a second. So what I would like to have happen is, as opposed to everything pivoting around that old line, okay, I'd like it to kind of pivot around this or expand around this. So since that's now the location line on the core face, the cool thing is if I go through and change things, okay, that's going to be the constant point. Okay, this one's interesting. That actually, I'll think about why that's the core. Brick on metal studs, but the metal studs are staying in the same place. Okay, a lot of detail. That probably won't haunt you till later, but if you put a whole building down and you later decide to go through and change the finishes, it's nice if the location lines are set up, because then the wall won't move on you. You'll sort of maintain the same amount of space. Okay, so generally makes sense? It may be a little abstract right now. It'll make more sense when you try to apply it to a building. Yes?
Drawing a little huge outline shape for the structure.
Yes.
Would you put all your location lines first on the walls, or put each wall?
Well, actually, what I'll tend to do is, just as I get going, I'll start by just saying, hey, I want all my location lines to be the core face exterior. And then I'll draw, in fact, let me show you. So let's draw some, okay, I'm going to choose some sort of wall. If you actually change the properties before you start placing the next walls, any property you put up here will then apply to all the walls that come here on board. You know, it's like setting a default property. So what I'll do is, just as I get going, say, you know, I'd really like these to be the core face exterior. And then I'll start drawing. Oh, let's put a nice curved wall section in there. You can sort of draw that and kind of arc that out a little bit. Maybe I'll come back here, come over here. But all these now have the same location line. And the groovy thing about them all having the same location line is later on now when I go through and change their properties, you know, they're all going to move relative to that same location line. Or they all have the same location line relative to them. Let me choose a bunch of walls. I'm going to choose a bunch of walls, and let me kind of show you a shortcut to doing that. Every individual wall you can go through and select. I can go ahead and click on that wall. I can click on this wall. If you want to grab a second wall, you can control click. That sort of works pretty nicely. If you have something like this, where Revit might actually be able to infer that that thing actually is related, because it's a bunch of connected walls that all have the same type. Okay? You can try tabbing, and it'll go rotate through different selections. It'll typically select a chain of walls next. So watch this. Okay, hover over a single wall. Okay, I'm hovering. Notice I'm not pressing anything. I just got the mouse hovering over that. Okay, it's got wall, basic wall. Here's the type of wall. Okay. If you, with one finger, delicately tap on the tab key, okay, but don't hold, just tap. Okay, it's going to rotate through and say, oh, well, you didn't want that. Maybe you wanted a chain of walls. Okay, and when that's highlighted in blue, you can then hit once with a mouse and grab them all. So that notion of tapping the tab key to rotate things, you're going to use it a lot. People kind of keep on coming in as one of those little shortcuts you use an awful lot. So you can try that if you want. I've changed all those. Oh, I'll give it some really fat wall type. And it expanded, but hopefully it expanded nicely with the studs staying in the same place, even though the finished layers came out. So location lines, one of the core or the instance properties. Again, it's not making a lot of sense now. When we start working with several different walls and different types, you realize like where that kind of comes in to help you. The other property we want to tell you about that's an instance property, it's a good one to think about controlling, is just the height of the walls. So let's talk about that. I just switched over to the 3D view. Again, if you haven't switched, don't have a 3D view right now, what you can do is, up here in the top, little quick access tools, there's a little 3D house there typically. You could choose that, and it'll pop open a 3D view. You could also, if you want to, it's just under View, 3D View, there's the default 3D view. That'll open it too. So if your model doesn't have one yet, make yourself a default 3D view. Okay. So I got all these walls, they're stretching around from level 1 to level 2 right now. And that's generally pretty cool. As you go through and create walls, you may want to sort of have, in addition to openings, sometimes just have walls at slightly different heights, offset to different heights, different bases. And for any wall we can go through, grab the wall, kind of stretch it up if it wants to be a few feet higher, a few feet lower, whatever it is. We can grab it by its top, we can grab it by its bottom. This notion of changing the tops or bottoms, we tend to describe as doing offsetting from the top and bottom. So let's talk about the wall and how it's defined. Every wall has an instance property which says there's the base constraint, let's tie the bottom to, and the top constraint, in this case up to level 2. Okay, that would have it evenly to level 1 or level 2. But if you wanted there to be a distance, like you said, I want it to go to level 2, but I want it to be a few feet higher. You want a little parapet, or you want some sort of architectural feature that just stretches a little higher. What you can actually do is put in something called a top offset. And that top offset's really just a number. It can be a positive number, like I want it to be 5 feet higher. It'll stretch it up. It can be a negative number, like minus 6 feet. And it'll depress it down. That's okay. This is sort of a very complicated wall, so there's all these little reveals and stuff in here. It's complaining that if I make the wall that short, it won't be able to do them all. And I'll just say okay to that for now. It's a very short wall right now. But the groovy thing about doing this with offsets, as opposed to sort of manually putting in a height, is that if anything happens where level 1 or level 2 changes, that offset will always be honored. So if you say it's 2 feet above level 1 and level 1 is 10 feet, it will be 12 feet tall. If it's 2 feet above level 1 and you change it to 15 feet, the wall will go up to 17 feet. So go ahead and whenever you can, specify things as offsets as opposed to hard numbers. Sort of, again, gives you sort of more robustness to your model. Go ahead and do it that way. Okay? So those are instance properties, but the instance properties are pretty easy. Most people get the instance properties really well. Okay. The more interesting thing to think about walls are some of the height properties and how the layers of the wall work together. And let's talk about that, because that's actually sort of a really good issue. Okay. Every wall has a type, and probably the most interesting feature of the type is what's called the structure of the wall. And the structure of the wall is really what determines the thickness, the material qualities, in terms of how it's going to render, the material qualities in terms of what its thermal performance is going to be. It all comes from the notion of the structure of the wall. And everything I'm saying about walls right now will actually apply to floors and roofs too. That the way we create new wall types or new floors is the same. We go in and we change the structure. You can say it has different layers and different materials we want to work with. Okay? And then we have that in our collection of different types we could apply. So let's take a look at the structure of one of the walls that are kind of built into this little library or the sample project. For example, I have a wall over there. It's called brick on metal studs. So what does that really mean? We can edit the type. you'll see that it has a width of 1 1/7/8, 1 1/7/8 inch in there. Okay, if we want to go through and change that width or thickness, we can say, well, I should do it slower. Edit the structure, and when we edit the structure, you'll actually see, this is how the wall is actually made up right now. So there's something which is called the core. That's the metal stud layer between those two. It's 6 inches thick right now. On top of that, heading towards the exterior side, there's some sort of plywood sheathing, some infiltration barrier, gap for air, and some brick on the outside. And on the inside, there is sort of a vapor retarder and gypsum wallboard. But really, the overall thickness of the wall is determined by all those things. And really, the thermal properties of the wall is determined by those things, as well as how it's going to render. All those things kind of come from these assumptions here. So if you do something like, okay, we want to go through and change the material or change the thickness, we can do that. For example, what if instead of gypsum board being 1/2 inch thick, if you could go ahead and put in 2 inch thick gypsum board, what would happen? The thickness of the wall would change. I didn't see much of a change here, but it actually did change the thermal resistance a little bit. Gypsum board has a little bit of R value, so you can go ahead and change that too. We can go through and edit any of these, but probably even better than editing these is let's go ahead and I'm going to open up the starting point file for the assignment and show you how I set up some wall structures for you, and then how you can change those to be different wall types that you might need. Okay, so what I'm going to do is just cancel out of this, and instead I'm going to go ahead and open up that little assignment file. I'll say open. I'll go popping on out there to where I keep those things stashed away. I'm going to go to the Stanford folder. I got the starting point file. Let me open it up.
I have a question.
Yes?
When you're using the tab command to select all the walls,
Yes.
And you want to extend the height, the wall height for all of them, is there any command to do it for all of them at the same time?
It should be. Let's try that. Oops. Not that. Let's go over here. I'll switch back over, and I'll go back to project 1. So here are all these walls. I'm going to just tab and grab them all. Okay, now, these are the instance properties. And what's happening for all these instances, they have a lot of things in common. Level 1 is in common, level 2 is in common. Column offset isn't in common, so it shows up as blank right now. It's an uneven selection. So if I put a value in there, like 2 or 3, it'll apply to all of them. Okay, so yeah, if you select many instances and then you adjust the properties, it'll apply that change to all the instances. Okay, now they're all popped up. Oh, nice. It's a good general technique question. Okay, I'm going to go back over here to this assignment file as a starting point. As you're looking at the assignment file, really, the only thing in there that's like a sort of a property line, kind of suggesting to you a boundary that you probably don't want to exceed. If your structure is getting much bigger than this, it's probably much bigger than 500 square feet. So that's all. That's a property line, just to sort of suggest things. If I go to the wall types or wall, and I choose some types, you'll see that we've set up in here for you just several different readily made walls. 2x6s with wood siding, 2x6s with stucco, 2x6s with shingle, different wall types to work with. 2x6s with brick. We should add stone. All what you wanted there. So, and how we would do that is, okay, I'm going to go through and put some sort of walls in here.
Is there a way to quickly check how big your entire thing is, how many square feet?
We'll show you that. Okay, I'll make this up to level 2. Up to roof, in this case. I'll draw sort of a very basic structure. Rectangles are very basic. Okay, let's take a look at that in 3D. Okay, you go zip it on down there. What did I actually choose? I chose wood and siding. And notice that here we have the walls all set up. They have this kind of yellow appearance, these kind of horizontal lines that are running across. That's supposed to look somewhat like siding. If I decide to change one of the walls to a different type, like shingle, okay, it'll apply a slightly different visual property to that. See if I can make that consistent colors. That might be easier for you to read. So that's a siding wall, that's a shingle wall. If I come back now and I make that, oh, not shingle, let's make it stucco, you'll see it has a slightly different visual appearance. So one of the things that you get out of the different wall types is the visual appearance. We'll also get the thermal properties. Okay, change that to brick. So we have some different wall types set up, but let's talk about how you can customize that. Because you may have in your mind some fantastic idea. Oh, I saw these really groovy composite panels. They're too, yeah, some other idea. And you want to put yours in instead of something I've given you. So how you do that is as follows. You can choose a wall, any old wall. Let's say edit its type. So I can switch types, or I can actually edit and change. Okay. If I edit the type and its properties right here, anything that's assigned that type will be changed. So often it's better to duplicate and create a new type. Okay. Same thing with doors and windows and sizes like that. It's often better to duplicate and change it that way. So what you do is we can say edit. Actually, I'll duplicate first. So 2x6 studs plus composite panels. Okay, we will edit the structure of that. So this wall, and this is the way I set them all up. Yeah, the wood frame layer being 5.5, the gypsum wall board, the truth is it's the same in all those wall types. I didn't change any of that. All I really changed was the notion of what the finished material is. Okay? So if you want to basically have about the same wall and just change the finished material, start with one of my walls, change it to a different finished material. And here's how you do that. Every material has a thickness. You can decide how thick your panels are. Oh, maybe these walls are 2 inches thick, or those panels are. Okay. On top of that, we can go through and change the material. I have it set to siding clapboard right now. Let's take a look at the materials you have to choose from. Over here in the materials column, you have this choice of, we can type in materials, but I often click this little dot, dot, dot button, which takes me to a browser. It shows me all sorts of materials. And we can kind of take a look at what's available. There's a lot of materials that are in there. Do some woods. Do some plaster. I can choose one of the existing materials and use it. Notice most of the materials have a color, they have some sort of surface pattern or things to them. Okay. Or what I'm going to do right now is actually just create my own material. So I don't see the composite panel I want. I'm going to go ahead and create my own new material. And how we do that is as follows. In the material list here, we have some choices down at the bottom, including creating a new material. So it's default new material. Well, that's not a very good name. Let me kind of rename that. I'm going to call it composite panels. Okay. We get to think about really what the properties of that are. So what do we want it to look like? What color should it have when we're looking at it in 3D? So I'll make it kind of a greenish color just so you can see it. Not that I think it should look green, but that'll be easy for you to spot. Make it a dark green. That's going to be perfectly ugly. Okay, we have the notion of a surface pattern. That is really what it should look like in 3D views and in elevations in terms of the line work that's on top of it. And we could choose a lot of things in here in terms of patterns. They have some patterns which are drafting patterns. I like to use model patterns. Model patterns scale. So if I find like 24 by 48, although it's a ceiling pattern, it'll apply the same basic hatch pattern to the walls. Okay, so I'm going to get something that's going to look like 2 by 4 grids. Okay, over that grid color. I can also go through and choose an appearance. An appearance would be some photographic appearance that when I rendered it, I would like to have a wrap on there. But we won't do that just yet. Okay. We can also put in thermal properties, physical properties. You know, as you build up your library of materials you like to work with, you start having a really cool library you can use for all these applications. You know, doing the structural analysis, doing the thermal analysis. But I'll keep it simple right now. We'll just kind of do this more as a visual exercise. So I've got some new wall type that has the composite panels. I know it's that because it has composite panels out here. Notice the thickness got a little bit bigger. It's just adding those things up. And when I say OK, and OK again, you'll see that that wall actually now has that type. So how do you make new panel types or new wall types? Go ahead, change the structure, duplicate, create a new one, change the structure, whatever you want it to be, okay? And then it's available to you. So if you want to have those green composite panels on everything, tab, and choose that. You know, whatever it is, go ahead and just apply it by changing the structure.
And whenever, if you were to export this file to something that, like an estimator,
Yes.
to get like quantity takeout and stuff, does he take into account those like materials that you
Yes.
combine?
You can have it actually report the quantities, so it'll know, you know, the amount of stud, the amount of sheathing, the amount of composite panel, whatever that is. And then in the estimating program, you'll go through and find in your cost catalog some material that you want to associate that with. Okay, yeah, whatever. It's actually very smart about that in terms of tracking that, and it can make a really big difference between the inside and the outside surface. In fact, just so you know, it's a really good question. Like even on these walls, you'll see there's these materials that have names like, oh, air infiltration barrier, but there's 0 thick. So why do we bother putting that in there? It's just so we can report the area of that, and later you can include that as part of your estimate. Okay, so no, this whole thing with the wall types gets to be really, really cool. Okay, so that's the basic rundown on walls in terms of getting going. How about if we do this? Let's go ahead and take a brief break since I started late and I still want to get you out relatively in time. If you can come back in about 5 minutes, that'd be fantastic. So go get a break, do a bio break, whatever it is, but come on back in about 5. And we'll keep going with walls and talk about curtain walls and show you a lot of tricks in terms of doors and windows and how that's replacing them in your building envelope, you can do things a little bit very efficient and like give you some control of that. Okay, so come back in 5.